Problem number 15, we have a wire of mass 3 grams, length 25 centimeters, and a magnetic field of 0.05 T. If this wire is levitating in space due to the magnetic field, we're trying to find how much current is going through it and in which direction does that current flow. So we have to use the equation mg equals the length of the rod times the current times the magnetic field. Then we work with that equation to solve for the variable I, which is our current. Then, given these values of m, g, l, and b, we plug that into this equation I to solve for the current, plugging in 0.03, 9.8, 0.25, 0.05, we get that the current flowing through the wire is 2.52 amps. Now we have to figure out what direction that is. So the problem tells us that the magnetic field is to the north, and if the wire is levitating, the force due to gravity is always pointed downwards. So the wire would have to experience a force upwards to counteract the force due to gravity. And upwards in this case just means out of the page or perpendicular to the magnetic field. So we have this equation, force equals V cross B, where V is the direction, V is the velocity of the current. So we have the force out of the page equaling the velocity crossed with magnetic field, which points north. So the velocity in this case, due to the right-hand rule, will be to the right or east, because if you have a velocity to the right, magnetic field up to the north, and a force out of the page, this velocity to the right is our answer, because that describes which direction the current is flowing.